One vital project expanded the plumb bob study of the effects of nuclear radiation on electronic fuse components and materials. The tests were conducted under simulated tactical and storage conditions, in which instrumented corporal missile fuses and allied components were buried in proximity to several bursts of kiloton strength. Magnetic tapes recorded the data for later recovery and reading. Fuses and numerous types of components were subjected to neutron exposures of from 10 to the 12th to 10 to the 14th neutrons per square centimeter, and gamma dosages of from 10,000 to 100,000 Roentgens. Since this project sought information on such questions as whether a missile during a multiple attack would function properly when a nuclear weapon burst nearby, it is noteworthy that many important changes in the electronic gear under test were observed. For example, some transistor parameters underwent transient changes 84 times their initial value without ensuing permanent damage. Plate currents of vacuum tubes changed up to 120%. Resistors exhibited decreases in resistance of from 10 to greater than 20% for periods of a millisecond. The corporal fuse system exhibited transient disturbances which indicate a high probability of premature firing when exposed to radiation doses as low as 10 to the 12th neutrons per square centimeter and 10,000 Roentgens of gamma. In the thermal radiation study exposing skin simulant specimens, both bare and covered with uniform materials, the objective was to validate laboratory methods of determining the degree of protection afforded by uniform materials under actual long-pulse megaton-type exposures. It was found that the field test results on the higher yield weapons differed in some respects from Naval Material Laboratory's predicted results. These differences indicated the possibility of a discrepancy between the laboratory's simulated thermal pulse as well as lower effective radiating temperatures of larger yield weapons. In a study to determine the rate of ablation of materials, metal specimens were mounted on a 100-foot tower within the shot cactus fireball volume. Recording equipment and thermocouples were buried at various depths within the specimens to determine the ablation rate. Another specimen within the fireball volume was designed to measure the velocity of sound from which the temperature within the fireball could be calculated. The method used involved recording equipment and transducers to pick up the pressure pulses from a series of small HE charges set off at sequential times after time zero. Data were obtained and recorded. However, thorough laboratory analyses must be completed before any conclusions can be drawn. The effects programs we have just reviewed were all successful in gathering a vast amount of data, much of which is yet to be analyzed. Ultimately, the extent of knowledge concerning the effects of megaton detonations will be greatly advanced. A brief summary of these programs indicates that soil types and yield are important in determining underground motions. However, simple scaling relationships are not apparent. Concurrent with the ground motion studies, the underground structures program tentatively confirmed the design recommendations for corrugated steel structures when extended to megaton range devices. Concrete slabs showed greater resistance to high blast pressures than expected. However, further analysis is required before quantitative results can be determined. The radiation program produced the first successful documentation of integrated neutron flux as a function of range for megaton detonation. Analysis of fallout from megaton devices is still being conducted by the laboratories, and any conclusions must await the completion of this work. In the structural effects studies on the B-52, sufficient data were collected to substantiate a correlation between measured and analytical responses. This will establish a workable and reliable side-load computation procedure. For the A4D and FJ4, sufficient reliable data were obtained for correlation with response data obtained during Operation Plumb Bob to permit subsequent defining of the high-yield weapon delivery capabilities of these aircraft. In the study probing the effects on a corporal fuse system exposed in a nuclear environment, it is concluded at this stage of the analysis that the system is electronically affected sufficiently to make its operation highly suspect. In the thermal radiation tests, it was found that a possible discrepancy may exist between Naval Material Laboratory simulated thermal pulse and actual pulses. The data tends to reflect a lower effective radiating temperature for larger yield weapons. As in most of the experiments on hardtack, it is too early in the analysis stage to make definite conclusions. These must await further study of the great volume of data gathered.